Okay, so we've got a rhombus. Before we start talking about area, let's get rid of that mess. And let's come here and make this a little bit bigger. And we can even make the rhombus a little bit bigger. Whoa. Whoa.
No way.
Yeah. Ooh. Okay. Good. Bella, what can you tell me about a rhombus?
The sides are all of the same length.
Good. Also known as, what's the fancy term for all the sides being the same length? Equilateral. Good. What else? Yeah, keep going.
It creates 90-degree angles when all the angles.
I like it.
in the
Good.
middle.
We'll put one in there for all four. Good. What else you got?
The diagonal angles are.
Um,
Are
I think so. Be more specific. What are you talking about?
like A and E are the same, and B and C are the same.
Good. So the opposite angles are congruent. Not only are the opposite angles congruent, but we also have all of these angles being congruent respectively. Okay, good. What else?
It's equal to 360.
What's it?
Like the angle measures.
The big angles?
Yeah.
So the big angle, CAB, ABE, BEC, and ECA.
Yeah.
Because it's quadrilateral. Good. What else?
I
Nick, you got something?
I was blanking now.
Okay. Sterling?
Opposite sides are parallel.
Opposite side, because it's also a parallelogram.
Right.
Oh wait, it's also a parallelogram? So if it's a parallelogram, how else can we find, how can we find the area of this thing? Yeah, so we'll put this up in the corner. Area is base times height. We can use that because it's a parallelogram, but we're also gonna get a specific rhombus formula.
Rhombus.
Okay, what else? Rhombus, yeah, R-H-O-M-B-U-S, rhombus.
That's how you pronounce it.
Why else would there be an H?
I think he's messing with us with the whole.
No,
I
when you
saw
question
Sylvie's-
your math teacher.
I don't know. I just.
Anyways,
How dare you?
what other chunks of information are we missing from the rhombus? There's one other crucial, well, there's a couple crucial pieces that we need. What about the diagonals, Jack? Other than the fact that they're perpendicular, because Bella already told us that.
They're different lengths.
Good. So AE can't be equal,
Oh wait.
can AE be equal to BC? But it doesn't have to be, right? What if AE is equal to BC? Then what shape do we have? Not only is it a rhombus, but it's also a square. Okay. Thank you, Max. Jack, what else about the diagonals?
Perpendicular.
We got that already. Thank you, Bella. No? Kayla? Good. They bisect each other, meaning? Okay, so that's equal to that, and that's equal to that. Okay, anything else? No? Looking at all those markings, what can you tell me about those triangles?
I saw Sylvie's.
Okay, hold on. By those triangles, if you answer the question, also be specific about which by the way, how many triangles in that picture?
4, 5,
6.
Six.
Oh, yeah. Like,
7.
no, 1, 2, 3, 4, 5, 6, 8. 8.
There are 8 triangles in that picture.
Okay, so you got the 4.
4 of them are right angle, or right triangles.
2 are isosceles.
The left and right are isosceles. The top and the bottom are isosceles.
Oh.
Okay. So, Kaylin, I heard you say that they are congruent. What's they? Which ones are you talking about? The 4 right triangles. Okay, so this is congruent to this, is congruent to that, is congruent to that. Okay, good? If we also go back and look at the isosceles triangles then, what's the comparison between that triangle and that triangle? Congruent, okay, and then you've also got the top and the bottom, this being congruent to that.
There's so much going on.
Yeah. So if that doesn't completely confuse you, nothing ever will. All right, we pretty much beat the rhombus into the ground. So let's talk about how to find the area of this bad boy then. We'll get rid of that mess. And put this back up here. Since it is a parallelogram, we can use base times height. How else can we find the area of that thing? No. Mary?
Well, since it's made up of triangles, you could use base times height divided by 3 times 1.
Say again.
Since it's made up of triangles, you can use base times height times 1/2.
Beautiful. Which triangles do you want to use? Do you want to use the right triangles? Do you want to use the left and right isosceles? Or do you want to use the top and bottom isosceles?
The left and right is.
Left and right isosceles. Okay, so we'll do, we're going to use this one. And we're going to use this one. So really all we need to do is find the area of the red triangle, then double it, and we got the rhombus. Okay, good. So let's do that. How do we find the area of the red triangle? Well, what's the base of the red triangle? Which side? BC, right? So you got to kind of look at it like this. So if the base is BC, where's the height? AD. So the area of this red triangle would be 1/2 the base, which is BC, and the height, which is AD. Okay. Then we could just double it, and we'd be finished. However, let's do it the hard way. Let's find the area of the red triangle. Let's find the area of the blue triangle and add the two together. What's the area of the blue triangle?
1/2 BC times
BC times DE. Beautiful. So therefore, the area of the rhombus would be equal to 1/2 BC AD plus 1/2 BC times DE. That seems like too much work, but if we do a little bit of algebra, these two terms have something in common. So if I factor out a 1/2 BC, I have AD plus DE. What's that? What's AD plus DE? The diagonal, also known as AE, right? Okay, so everybody good with this?
Yeah.
This works great for this specific triangle, or this specific rhombus, but what are those two lengths? They are the diagonals, correct? So therefore, we can't count on every rhombus being labeled A, B, E, C, but we can take this and generalize it into a formula that says the area of that rhombus is equal to 1/2, because we still got a 1/2 sitting there. We're going to call it D1 times D2. D1 is one diagonal length, D2 is the other diagonal length. Okay, so suppose Mary changed her mind here and didn't want to use the left and right isosceles triangles. Suppose we wanted to do the right triangles. I could go through this same procedure again and find an expression for the area of that triangle. What would the area of that triangle be in terms of the side lengths and the rhombus? Max?
1/2 AD times BD,
Perfect.
and then
could multiply it by 4, or we could do all 4 triangles. So then the triangle in the upper right would be 1/2 DE times BD. The one in the lower left would be 1/2 AD times DC. The one in the lower right would be 1/2 DC times DE. You write out that big long expression, and then I'd have to do the same thing I did here. When you factor out common terms, you'd end up with the diagonals, which will get us back to that puppy. Okay. This is also relevant and usable. Since rhombuses, rhombi, are parallelograms, we can also use the parallelogram formula there. You can use the parallelogram formula on the rhombus, but you can't use the rhombus formula on parallelograms. It doesn't work that way. Okay, we good? Go.
So D would be, what would,
In this case, D1 would be this.
and then
D2 would be that. So D1 and D2 represent the entire diagonal length. Okay, we good?
Yeah.
All right. Let's move on to a kite then. Okay, quick review of a kite. What do you got, David?
The diagonals are perpendicular.
Good. It's a good start. What else?
Aren't angles D and B congruent, but then not A and C?
Angle ADB is congruent to angle ABC, but you're right, that angle on top is not equal to the angle on the bottom. What else?
The diagonal that's horizontal is being bisected, but not AC.
Right, it won't always be horizontal, just in this particular case. Yeah. Okay, I'm with you. Good. Anything else?
Side length DC and BC are congruent.
Okay, this is congruent to this.
And DA and BA are congruent.
Anything else?
That's all I got.
Okay. Tegan, what else you got? You did a pretty good job. There's a couple little things in there that might help us, might not. Can you tell us about triangles?
Okay.
By the way, how many triangles?
Eight.
Six.
8 again. Back to you, Tegan.
Triangle ABE and ADE are congruent.
Triangle ABE and triangle ADE are congruent. Good.
And then triangle DEC and BEC are congruent.
I like it. Uh-huh.
And then ADC and ABC are also congruent.
Okay, so the left half in this case, oh, that's a bad color choice, is congruent to the right half. What about the top and the bottom isosceles?
They are not.
They are not congruent. Good, so those won't help us at all. Did we miss anything? One small thing we missed that's not crucial and not going to be a big deal, but that angle, whoops, wrong color. This angle is equal to that angle is equal to that angle. Other than that, and this angle is equal to that angle, and this, yeah, okay, so anyways. Good, pretty much beat that into the ground. How do we find the area of that thing? Which triangles? Is that you, Jack? No? Emil? Which triangles you want to use?
bottom and top. No, left and right.
So you want to use triangle ADC.
Yeah.
and ABC. Awesome. Okay, so the area of triangle ADC is 1/2. Which one's the base?
AC.
Good, you gotta look at it like this.
Yeah.
AC, and the height is
DE.
DE. Good. And then if we look at the one on the right, we would have 1/2 the base, which is
AC.
AC, and the height, whoops,
B.
hold on, typo. AC and
BE.
BE. Repeating the same process we used with the rhombus, we get 1/2 AC times, what's DE plus BE? DB. What's that?
We just added letters.
I'm sorry?
It's weird, we just added letters.
Those are letters, yes. Geometrically speaking, what is that?
The diagonal.
Diagonal. What's this?
Diagonal.
So therefore, in general, we can write this as 1/2 D1, D2. Same formula. Ooh, that'll make things a little bit easier. How does the kite change from the rhombus, though? What can't you use with the kite? Yeah, base times height, because a kite's not a parallelogram. How many unknowns in that equation? Area equals 1/2 D1, D2. How many unknowns?
3.
There are 3. Given 2, you should be able to find the third. So D1 and D2, if I give you D1 and D2, easy plug and chug. If I give you the area in D1, you should be able to find D2. And if I give you the area in D2, you should be able to find D1 for both of those. Okay. We good?